Hi, good morning, APE students. Hope you guys are all hanging in there and practicing some social distancing. I miss everybody. So we're going to take a look at energy conversions and efficiency in this virtual lab. So you should have downloaded a chart document um, entitled Energy Conversions and Efficiency. You do not need to format it that way as you record your answers on lab notebook paper or scratch paper. Just make sure that everything is clearly labeled for what station you're doing, and then I can see your work with answers. So the first thing we want to look at is station number 1, in which you're going to learn how to calculate kilowatt hours. You're not going to be doing station number 2. Notice that the only thing I'd like you to do for station number 2 is answer that question about vampire power, often called phantom power or phantom energy. In station number 1, we start by using something called a kilowatt meter. It's a power meter in which I can plug my electrical device into the kilowatt meter itself, and then the kilowatt meter gets plugged into the wall. We're going to use data to answer a couple of different questions after we've got all that data collected. So what I did was I measured the amount of wattage for 3 different types of light bulbs to demonstrate the idea of efficiency and the second law of thermodynamics. So you can record that for the incandescent light bulb, I just set it up, plugged the socket into the kilowatt meter into the wall in the lab, and it recorded 75.9 watts. So you can put that in your data table. What you're going to do then is calculate the number of kilowatt hours that your device uses. So if it had 75.9 watts, there's 1,000 watts in 1 kilowatt. Notice that it said that I am going to be using the device on your data table for 6 hours per day. So 6 hours per 1 day, 365 days per 1 year. When you do these energy conversions, you definitely want to demonstrate the cancellation of units. So watts cancels, day cancels, and this is probably a new unit to you. A kilowatt hour does not involve cancellation. A kilowatt hour is kilowatts times hours. So I have 75.9 times 6 times 365 divided by 1,000, and my unit is kilowatt hours per year. You can go and do a search for the Marshfield Electric Company website and find out what our current cost of electricity is. Obviously, if we have a conversion like this on an FRQ or even in a multiple choice, they're going to provide that information, but I'll let you go ahead and find that. You're then just going to repeat that for the compact fluorescent bulb. Here's the wattage for that in the kilowatt meter. The LED bulb, the 10.4 watts for the LED. And then the next thing we want to look at is what is happening to that in that electrical conversion. You're going to answer the type of conversion that's involved there. But I set up an apparatus as you would have done in lab with a big old cardboard box. A hole on one end has that light socket with the 3 different light bulbs that we can plug in there. On the other side of the box, there is a temperature probe and a light sensor that's going to measure the luminescent. So here, for example, after running for 180 seconds, so 3 minutes, not too long. For example, the compact fluorescent bulb, you can see what happened to the temperature and you can see the illumination. Notice that my x-axis is time, my dependent variable, and that I get the temperature and the luminescence measured in lux. That's just a unit for measuring the luminescence or light output of that light bulb. And it looks like it probably took, after turning it on, it took a little bit of time for that to reach its peak light output. So you may want to kind of jot this data down because it's what you're going to use as some evidence to support a claim at the end. When I look at the compact fluorescent bulb, for example, my change in Y for temperature, remember Y was my temperature scale, so this is delta T. Over that 3 minutes, it increased in temperature by 1.1 degrees Fahrenheit. And notice the average illumination or light output for this compact fluorescent bulb. For the incandescent bulb, whoa, we have a delta T of 5 degrees. So in 3 minutes, that incandescent light bulb heated up a total of 5 degrees when it was inside that enclosed box. And here is the light output. Interestingly, I tested the LED light bulb last, and this is kind of an interesting thing. The temperature actually went down. The temperature started a little bit high. I think that after testing the incandescent light bulb, there was a little bit of heat trapped in that box yet, and it didn't cool off efficiently. The slope of the line for temperature was actually a -1. I think it's fair to say that the LED light bulb really didn't heat up at all. And then notice that in terms of graphing the luminescence over time, that it got up like really quickly. It was able to get up to that light output and obtained a mean and rather consistent luminescence. So your analysis is to calculate the kilowatt hours per year for all 3 devices, the amount of money used to run each of the different light bulbs, and then answer these questions as your summary. Next, station 3 and 4. This is looking at another method of energy efficiency using what we call Energy Star appliances. I will have you note that you're calculating this based on the total number of TVs in the United States, as well as the total number of refrigerators in the United States. The data that you need to do that is provided here. Here's a little bit of analysis. If you think about what they're going to ask me in an FRQ, they're really going to focus on what are some solutions? How can we reduce our energy consumption? So you can take a look at some ideas here for writing that conclusion or the analyzing your data. For stations 5, 6, and 7, unfortunately, I forgot to record a picture of the hand generator, but there's a short video that shows the photovoltaic cell. This is just a PV cell, and you're going to see it run a little motor. I also don't have the wind turbine video, but you can go ahead and answer all of these questions. If you're looking at your original document that you downloaded from Canvas, you can go ahead and scan those codes in order to answer that question. So you can play the video of me running the photovoltaic cell, the PV cell, and then here's just a super cool video. Hopefully it makes you think of me, because we could all just have these desks in our classroom and it would be amazing. That's all for the efficiency lab. I'm going to cut this short so I can get it loaded. Have a great day. I'll talk to you tomorrow.